Okay, how's it guys? Today I just want to take this opportunity to demonstrate some new development I've been working on with regards to the actual bifin and the added dynamics of the bifin. I think all of us are familiar with the desire to be able to change the surfboard's dynamics, whether it's a full-scale board, even an RC board, and one of the dynamics that's really important on an RC board really is the ride attitude of the board. In small surf, really small waves, because we can't distribute our weight backwards, we have the desire to want to get the nose up so that we don't pull too easily in the smaller wave pockets. And in bigger waves, in really big arching turnbacks, cutbacks and bottom turns, etc., etc., we actually want more of the length of the board in the water so we can power those moves a lot better. So without modifying any parts of the tail of the board, I wanted to find a solution where I could really just change out a component of the board that would lend itself to changing those dynamics. And what I've been playing with, and it seems to be working quite well, is the actual bifin and playing around with the toe in and toe out of the bifin fins. So what I'm going to demonstrate on the water here today are three various bifins: a neutral bifin, a toe in bifin and a toe out bifin, and try and show you the dynamics actually at work when we're on the water. So let's go. So as you can see on this particular bifin, it's narrow in the front, wider at the back, meaning that the fins are actually towing in the forward motion. So what effect that'll have, it'll actually draw the tail of the board down, lift the nose of the board out, and that's what we're going to want in smaller, hollower waves. So let's put the board on the water. Let's see how it draws the tail down and lifts the tail out, the nose up. Nose up. Keep the nose up. Get there with the nose riding high.
Yep.
So we can see with this bifin that the nose is definitely riding a lot higher by comparison. Also in the turns, you can see when we turn the board, the nose is very up. Down the water, left rail. The left rail, left rail in the water. And we can see it transform a little bit on the tail there. You can see that the tail's been drawn into the water a bit more. Managed to capture a bit of that, Jessie?
Yes.
Right. So now we've changed to the toe out fin, where you can try and see, just get a better light here, where the front of the fin is wider and the back is narrower, meaning that the two fins opposing each other are towing out, which will in essence, when I'm riding now, have the characteristic to lift the tail of the board and put more length of the board in the water. And that I find very helpful when I'm riding bigger waves on very windy waves, when you have a tendency to be going down the line and the wind's getting under the board. The more I throttle it, the more it actually puts more board in the water. So in effect, it's giving us a weighted dynamic, in essence, almost like a Formula One having an aerofoil that's pushing the car down on the road. This is in fact pushing the board into the water. So let's see that on the water. So you can see the board riding out a lot more wetted area, lower nose, more board in the water. I might just jump over it here. You see, the harder I throttle, the more the board is in the water. The harder I throttle, the wetter the board is in the water. And that's really great for when you're running in windy conditions. Even if I'm running, you see in the turns of the nose is slightly lower. You get more rail in the water. It'll be more powerful arch turns. Board hold. The bigger turn is more. see as I've got here, there's more board in the water by comparison. Okay guys, so here we actually have a neutral biofin where you can see the gaps between the front of the biofin and the back are equal. The fins are parallel to each other. We'll call that a neutral biofin. And in essence, what it would mean is that this biofin, in lift, in forward motion, is not going to have any effect on lifting the tail or putting the tail down into the water. And I would say this biofin is the sort of most used one, preferably in surf from about 4 to 6 foot. Just find that it works well, and obviously it'll also be the most efficient biofin because it'll be using less drag than either the toe in or the toe out biofin. So let's just see how this runs on the water so we can compare the other two biofins with the boards riding on it. Definitely see that the board is quicker. Have a tendency to lift the nose or push the nose down to stay very stable. Very good all-round fin. All the fins have the little winglet on the left fin that counters acts to the prop's rotation. So that's still a squeeze on each fin.
That's getting me wet.
Okay, so as you can see, subtle differences, not massive differences, but those subtleties, like normal surfboard fins, make a difference in the surf conditions that you choose to be in. And be it ever so small, that one little pearl or that one blow off on a wave can make the difference to a great ride being spoiled or made. So yeah, just something simple, one little grub screw, change the fin out, and have that subtle difference to enhance your surfing experience that much more. Take it easy, guys.